All right, bang. Today we are going to talk about what the fuck is dspy, because if you don't know what it is, I can almost guarantee that you'll be hearing about it in a couple months. Whether you're on a team that's trying to build like AI automations or you're building agents, I think the principles of dspy or dspy itself will be super popular, kind of like MCP was at some point. So I want to talk about like what it is, and then give some examples, and then after that, we'll see a little bit more in detail how it works. Okay, so dspy, it's a weird name. It's from Stanford, and so you got to understand that it has academia roots, and so with that we'll see some quirky things, but we have to understand basically what the problem that it's trying to solve is, and then we'll be able to understand what dspy is. But first of all, let's get into the name, because if you understand what the name means, then you kind of understand what dspy is. Okay, so dspy stands for Declarative Self-Improving Python. And so the first two words here are important. So first, let's talk about AI programs, AI applications today. So in every AI application, you have the LLM, you have tools, and you basically put them in a running loop all the time, where that you basically give a prompt to the LLM, and then it kind of works to do something using those tools. And you make calls to OpenAI or whoever you pick. So this is what you would call imperative. You're writing a program that orchestrates all of these components and explicitly says how you want something to be done. And so you can think about LangChain, or any time where you're like making a call to the LLM, and then you're gonna pass that output to a tool, and then you're gonna pass that output back to an LLM. And that could be the flow of one AI application. Or then like you do that, and then you're gonna put it into a loop where the LLM has like tools and whatnot. So that is imperative programming. And it's kind of the same thing as like programming in jQuery before React existed. That's imperative. But dspy is declarative, meaning it forces you to describe what you want to happen, and then dspy will do it for you. Like if you're coding React, or you're programming what you want to happen on the page, but you're not necessarily incrementing every counter and keeping track of the state yourself. Okay, so self-improving is another crucial part of dspy. And that's basically trying to get you, instead of prompt engineering, to do prompt optimization. So when you're doing LangChain and stuff, the prompt is super important. Like I'll show you some examples of where you're like explicitly telling LLM like, do this, and I need you to follow these instructions, or else this app won't work. And you need it to output specific formats, and you need to know how those formats are. You need to give it examples, and you need to have like this huge prompt that makes things work well. But the fact here is that dspy will be able to build that prompt for you if you give it some examples to train on. So we'll see what that looks like. Okay, so getting into some more specifics, there are 3 building blocks to dspy: signatures, modules, and optimizers. So is get a little confusing because this is academic, like I said. So signatures are basically the I/O of all the specific components of your application. So you define an input and an output of some something that's going on. And then a module is like the core building block in an application. So it could be like extract data is one of these modules, and then you have an IO for that module, and you would specify the inputs and the outputs. And then the optimizers, so say you build a module, then an optimizer is what, and you give it some examples. So the input to an optimizer is examples, and the output of an optimizer is tuned prompts, and like it's called a compiled. So basically a dspy program that's ready to run. Okay, so let's take a look at a real example. So say you have a support ticket system, and you input this support ticket that's just a blob of text, and then you have some specific things you need to get out of it, and then give it to the right team or something. So it's just a text input and then some structured output based on the content of that text. So this is what it would kind of look like in some code. So here we're creating our own module, and this is kind of what you would do in most dspy programs. So inside of the module, you have these are like four modules are composable. And so you're composing some of the pre-built ones. And then in this forward pass, basically every time you're running the agent, this is what happens. So it goes sequentially. And then it ends in this prediction module based on some of the extractions here. So you can see like there is no prompts in this code because dspy will essentially build them for you. Okay, cool. So that's an initial introduction. Let's look at some code. Okay, so here on the right is a traditional, just like very simple call to an LLM extracting structured data, where you constrain the response format, hope that it outputs correctly, and then call it a day. But if you wanted to make this perform really well, you would have to measure its success. And say you would want to trial and error on different LLMs, maybe you would want to find the cheapest LLM to use. You would basically have to build this like evaluation pipeline yourself. But dspy is basically built to force you to do that and make it really easy. So this is what it would look like with dspy. It looks a little complicated. It was actually like very similar. We define the same class, same data model, and then you extract given some descriptions. So here's the signature, and here is the module, and then you put that together into your custom module and then run it. And then all you have to do is compile some examples, or put together some examples, and then you can compile this to perform better, and then you can measure its success with an eval. And then all you would have to do to switch out the LLM would just be change this to Anthropic or something. And then you could run the same eval and it would work every time, the same exact way. Okay, so that's a bad introduction to dspy.